Okay, let's take a look at example number 2, and we're going to generate shells about the x-axis. So they want R to be the region in the first quadrant that's bounded by this graph and this line. So I'm going to go ahead and draw that out. So what we have let me get this thing set up here. Okay, there we go. So what we have is a coordinate system here. We're bounded in the first quadrant, and we had the two lines. So we had one line, I'll call it f of x, is equal to the square root of, I believe, 2 minus x. Let me go back and check. I'm sorry, x minus 2. And then another line, we'll call it g of x. It's irrelevant. But that'll be the line at a height of 2. So what does this look like? We should get a picture out first. So let me go to Desmos, just so that we can see. So we've got the square root of x minus 2. So there's that guy. I'm going to come out a little bit. And then we also have y equals 2. There's a flat line like that. So what we're looking for is first quadrant bounded by these two guys. They're looking for this piece right in here. Okay, so let's go ahead and draw that out again. So we've got one curve that comes out like this. This comes out like this. So this guy's is f of x. This guy's is the graph represented by g of x. Okay, and what we're trying to do is we're trying to take this, this area right here and revolve it around the x-axis. Now here, this is obviously 0. This is up at a height of 2. And this guy over here doesn't start until 2 over, right? Because if you plug in 2, you get 2 minus 2, which is the square root of 0. So that's this guy right here. Okay, so that's here. So we need to take this guy and spin it around. Well, what we need to do is we need to take a look at one of the shells that's created. So one of the shells will look something like this, right? And it's super thin in the middle, like that. Okay, so that's one of these guys that's been rotated around. Okay, I don't know which one it is. Now I do know that this would be where the x-axis is. Okay, and then up here would be the y-axis. So we've got that situation where we came around. Now what we need to know is the following. First, let's take this guy and let's lay it out. Okay, so along the y-axis, okay, we're going to lay this guy out. Okay, so it's going to have some certain height, a little bit of width there, well, certain length, certain height, and a little bit of width. So we just laid that guy out. Now what we need to know are the dimensions of this. Okay, that'll help us get this here. So the first thing is I don't know how far the radius went out. Okay, all I do know is that it went out some y value. So we'll just call this some arbitrary y. It doesn't matter. I mean, we could be talking about the cylinder that came out here and then got wrapped around, right? So I don't know. Let's just call this some random y. Okay, so this guy over here is some random y. So that is literally is this length. It's the radius. So the radius of this cylinder is some random y value. I don't know what it is. Okay. Now this is arbitrary because it's going to change, because as the y value goes from 0 to 2, this y star will change from 0 to 2. Okay, so that's where this comes from. Now what we need here is to figure out the distance or circumference around, which is this guy, this length right here. Okay, We know the circumference is equal to 2 pi times the radius. So for us, it's 2 pi times the arbitrary y value. Okay. Now the height of this guy, well, the height depends on this line right here. Right? The height changes, and how does it change? The height changes according to this function. But the problem is this function is written in terms of x. So let's write it in terms of y. The reason we need to do that is for our integration. We want this whole thing to be in terms of y. So this means that y squared is equal to x minus 2, which implies that y squared minus 2 is equal to x. What does this mean? This means that if I graph out y squared minus 2 is equal to x, that'll give us the same graph as y is equal to the square root of x minus 2. Let's go ahead and check that out. Okay. So I already have y is equal to the square root of x minus 2, so let's do y squared plus 2 is equal to x. Now notice what you got here. We got the top half and we got the bottom half. And we got the bottom half here, this extra piece, okay? Because when we squared both sides, we came up with all of those negative y values, which weren't possible here. Because look at this equation. Y is equal to this thing. This thing can never be negative, right? It's a non-negative number because the square root of anything is 0 or greater. But this thing over here, I can plug in a negative value for y and still come up with an x value. So that's this piece right here. So it's extra, but it's kind of nice because it gives us the other side, right? It shows that whole piece. But again, these two are essentially equal to one another, except for this piece right here, which we're not going to worry about. Okay, so each of the height values is given by this. So that means that the height of this box is whatever y star was squared minus 2. Okay? And now the depth of the box here, okay, is given by delta x. So what do we have? Well, to find this volume here, the volume of just this one guy, well, it's equal to 2 times pi times y star, the base, times the height, y star squared minus 2, and then times, whoops, I said delta x. It's not delta x. It's delta y. And let's talk about why it's delta y. You get so used to writing delta x. So delta y. What is delta y? Well, look, as we form this thing, it has a small width, right? You can see that little width here. Okay, that is this length right here. That's this guy right there. Okay, but this is just a super small change in y, right? Because it's changing the y variables from here to here, so it's a super small change. Okay, and so we have this delta y, which is a super small change, the thickness of this arbitrarily picked cylinder. So we got this. Now, what we want to do is we want to add up all possible cylinders. So I just took one little one, but I want all of them. There's an infinite amount of them. So what I want to do is I want to add, when y goes from 0 to a height, 0 to a height of 2, of these guys for every single y. So instead of just a particular y star, I'm just going to use y. So this will be 2 pi y times y squared minus 2 dy. Okay. So let's go ahead and play around with this. Well, the 2 and the pi can be pulled out. So this would be 0 to 2, 2 pi. This inside here will be y to the third minus 2y dy. And now what we do is just find an antiderivative. So this is being 2 pi times y to the fourth over 4 minus y squared evaluated between 0 and 2. So this will be 2 pi times 2 to the fourth over 4 minus 2 squared Okay, I'm gonna go like this. Minus this guy evaluated at 0, which would be 0 to the 4th over 4 minus 0 squared, like that. But this guy is just 0. So this will be 2 pi times 2 to the 4th is 16, divided by 4 is 4, and then minus 4. There's an issue there. Let me go back and check. Give me 1 second. Okay, the magic of doing a video here is, although that took me a couple minutes to find, you only got to see, well, I don't know, 2 seconds of my mistake. So here's the issue. Here to here, what did I do wrong? I have to add 2 to both sides. And I knew this was wrong because I would have got a volume of 0 and that makes absolutely no sense. So this should be plus, 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 and plus. So this will give me 2 times pi times 8, which is 16 pi. Okay, that's how we go ahead and get that solution.